So just before we start the video, I wanted to ask you guys to let me know if you like this type of content by subscribing and liking, so I know from which videos gets the most traction. So if you want to help me out, just subscribe and like the video. Thank you very much. Now let's go to our 3D world here. So all of this just finished the fog of war texture in our 2D environment. So for our 3D environment here, let's create a new script. So let's create a variable to be our world size. Now this world size idea is that it represents in meters. So in 3D it's going to represent meters, but when we use the fog of war texture on 2D world, this is going to represent pixels. So for each pixel is going to be equal a meter, and this should give you a good performance. So we also want here to grab our Godot ball that we're going to use to track our fog of war. And now that we have created our fog of war texture, let's actually add to our world here, and let's add inside of here. This is going to be our fog of war texture, and finally we want our 3D mesh of the terrain world. And now let's copy this dissolve sprite we preloaded back to our world. So we're going to be using that inside our world. So now let's go to our ready function, which is going to set up a couple of things here. So on our ready world, we want to grab our fog of war, and I'm basically going to be adding this right here. So instead of passing here that, we're going to use the world size here. So we want to create a new fog of war by creating at the top left position and by using our world size from the world node here. Next, we want to add a unit to our fog of war. Now before we do that, let's create a new function here. So this function basically is going to create a new image resized to a given size we want. So this is just to simplify things. So say you want different units with different fog of war, instead of you preloading different images for each of those fog of war dissolved sprites, you can basically resize the same image. So we are going to be resizing our fog of war dissolved sprite by the given size here. So we do this by creating a dissolve image, and this is going to use our dissolve sprite get image. So the preloaded resources we just did as an image, and we want the dissolve image to be resized by the size we just give. And finally, because we are returning a image texture there, we just need to return a image texture here, which is going to be created from the image, our dissolve image. So now we're going to use a new function to add the sprites and assign them back to our Godot ball A. Go ahead and say a add unit fog of war sprites. So this basically is going to create a sprite for the given node 3D, so we can use as the fog of war dissolve later. So you are going to do this by creating first the sprite. So now we are adding a sprite to the fog of war texture node inside its 3 node. And it's going to have the dissolve sprite we just preloaded on the top there. And we also are going to be adding under our units data, so it keeps a track of the unit we just added. And we want to have the instance ID here. It's unique, this entry, and we can actually put a space here just to make it more visually clear. Next, we want to put in the node we are going to be tracking the position of, and then in this case it's ball A. And next, which is the sprite that we're going to use to be updating, which is our new sprite that we just added here. So with this, our fog of war should have the information needed to keep updating the fog of war to the ball A. And I can actually rename this to add unit fog of war, because it's not just the sprite, we're also adding the unit data here. So now we can just say add unit fog of war ball A. And now if we run the scene, you should see the sprite here following the ball wherever it goes in the 3D world. And I saw that the size is wrong. So here on the new sprite, let's set the texture to be a little different. It's, let's say, a size 32. So we're basically creating a fog of war sprite texture, which is just 32 using the fog of war. So that should make that sprite a little thinner. And as you can see, it's pretty more small. And if you're seeing this, you notice that the coordinates are not matching. And that is simply because here on the fog of war code, this should be Z, not Y. So the position to 2D here, it's wrong. So now if we run the scene, this should be the correct one. And as you can see now, the 3D coordinates are matching the 2D coordinates here regarding the world 3D. And you can see basically the fog of war dissolving right there. So this is already working as it should. So now the last thing is just to get this fog of war texture image on top of the terrain here. So for us to update that, let's go through our shader here. So now it's time to actually create the part of the shader that is going to overlay on top of this. So we already have the terrain mixer shader here. The only things we're going to need is a new texture. So I'm going to add a new uniform sampler 2D, which is going to be the source texture for our fog of war. And here I'm not going to pass as a source color, because if you don't declare source color, it's going to treat as information. And because this is a fog of war, this is going to work just as expected. Now that we have created a reference for our texture, we can basically go here on our fragment shader and generate that new texture here. So our texture for the fog of war is going to be equal to a new texture, which is our source texture fog of war. And here's the important part, UV2, and its RGB value. So the important part of this shader now is that we are using UV2 coordinates, which we need to set up on Blender with this terrain as the top view projection regarding UV as 0 and 1. So, and actually it is like this, I believe, which is 0 and 1 coordinates. So this should work appropriately. Now we have our shader and we have the texture saved here as a vector tree. So now we just add it on top. And for you to multiply it, it's simply adding multiply by the given texture. And because it's RGB, it's going to multiply. So after we mix the terrain, we are basically going to multiply to the source texture FOV. I don't know if I can use the sprite, so yeah, I can use that. So you can see how this is basically going to work. We have our textures for the terrain mixer, and we are going to grab the texture from the fog of war texture controller here to be saved under as a new texture here. And by using a multiply function, the black portions should turn the texture black and the white portions should turn the texture non-editable. So it's not going to change anything. And any lighter grays is going to just keep it. So this now should work for the shader. Now the last thing is we need to update the shader texture FOV every time we update it on the fog of war texture here. So here on the fog of war, our 3D world, we can ask for the fog of war signal. FOV updated, that's the name of the signal. We can connect this to a function. So we're going to generate a small function here. This is a lambda function. So we want to first grab our shader. So the world mesh dot get material override, I believe I assign it, and it is a material variable under the geometry as a shader material. So then we can later set a shader parameter. And let's give it the parameter here, and I'm going to roll over and copy the property path, that parameter. So this is the parameter to set it up. It's the source texture FOV, and we want to set it up using the fog of war viewport texture. So let me grab it right here. So the fog of war that we're going to save by each tick, we are going to use it on here. So this should update our fog of war every time the fog of war is being updated, should update the terrain. So now if we run the scene, we should see the fog of war in action. And as you can see here, there's the fog of war. So there's something wrong with the coordinates here. And there is another thing that I didn't cover. You can see the terrain here as a kind of a shine to it, so it's not fully black. So what we can do is go to our shader on the terrain. It's actually throwing an error. Oh, and the format is different somehow because this is a compressed image. So let's just test if lossless can fix it. It seems that the dissolve function is not working. So as you can see, now it's working properly. We can see the fog of war being revealed. But there's something wrong with the size of the image is not matching the world here. So as you saw, this is now imported as a loss method. It worked. So you just have to test as well the compressed methods. So what is happening here? It's that our texture is not scaled properly to the size of the world here. So one of the things we can do to fix it that I forgot to set it up is once you create a new fog of war here, we are dividing its size by 2 so we can have the half of the map size. So now this should work as expected. And the next thing I want to address, so if we run our scene now, it should work as properly. You can see now the fog of war is basically working. We have one last issue to fix here, and it is on the shader side. So if you saw the shader, the issue we are having is that the black portions are not actually pure black, and that is because of the specular of the shader. So if we go to our shader here for the terrain mesh, we want to set the specular to be multiplied by our texture FOV red channel. So this is basically converting that to a grayscale value by grabbing one of the channels. We're basically multiplying our specular for the entire world 3D mesh by the texture FOV. So now if I add that transparent here, I think we can do a test. You can see if I comment the specular section, you should be able to see a greenish color here around the mesh. So this is the result of the specular, so this is basically a diffuse material here. So if we multiply the specular by the texture FOV, the black portions of the texture will turn the specular also darker. So now once you run the scene with this new addition to the shader, now it should work as expected. And as you see here, now it's working as it should. Terrain is full black, and whenever our units move around, we're going to review parts of it using the coordinates of the 3D ball to a 2D here on the top. So as you can see, this is the concept proof of it. Now the last thing remaining to do is to display objects as we explore under it. So now if we wanted to add, let's add a mesh instance, and let's do a triangle mesh here. Let's make it quite big here. Let's put like 12 by 12. We have something to display once the unit crosses it. So this on your game can represent a tree, a object, a building, an enemy, whatever you wish. To our area 3D to be inside of our Godot 3D ball here. So let's create a new area 3D first. And let's give it a new collision shape, which is going to be, let's just say 30 or something. And we can check if this size is appropriate by doing a visible collision shapes. And once we run the scene, we should be seeing now the collision is way off. So let me just resize this to 15. So at size 14, this seems to work roughly the same size. Now we can disable that debug. Now let's go through this tense object here. So it's going to have a static body 3D, then it's going to hold a collision shape. Now the collision shape here doesn't matter. We are going to be making it a sphere because it's the cheapest. So once our unit collides with this, it's going to reveal it. So let's move our static collision a little bit downwards, so it's roughly on the base of the object. So now for us to review or hide an object is pretty easy and simple. Here on the code, let's just grab on our world here, let's grab our Godot ball. So our ball dot get child, and this is the only child as area 3D. So we're grabbing the first child of the node 3D ball, so it's going to be the area 3D. and we are going to connect its body entrance. So connect, and we're going to create a simple lambda function here. So void, and let's say, and also this function, I believe it returns a node 3D. Okay, so the node 3D, we just want to display it, but show. So this should take care of it. Now the last thing to do is to make our object start as hidden. And we can do this in the editor, or we can add another node 3D. And we can say dynamic objects. And you can basically put it inside of it. And here on the start of the world, we can basically say for units, for dynamic object, and let's pass the reference for this. Dot get children dynamic object dot hide. So basically it's going to tell that for every dynamic object inside the dynamic objects to start as hidden, and whenever our 3D ball collides with it, it's going to run with any body entered, it's going to ask to show it. So this should work now just like Age of Empires. So if we test this, we can no longer see the dynamic object. Once we collide with it, we should be able to show it. Now that didn't happen. Let's see the collision shapes here. So there's the collision there. Let's see if we actually are hitting it. And we are, so there's something else here. Like what seems to be the case is that we are colliding with a static body, but what is hidden is its parent, the mesh instance. So there's nothing wrong. We just need to body dot get parent show. That should fix it. Now for on the scene now, that should work properly. Once we cross that, it's going to grab the parent of this collision object, and you can see the tent. And obviously it's on the path there. So there we go. Now you have a system just like Age of Empires, and you can just keep placing here other objects. It's going to work as it should. My example, I had a little more mesh to work with, but the idea is basically the same. But yeah, now if we run the scene, all objects should start hidden except the terrain mesh. And once we cross those objects, we should start showing them. And as you can see, it works as it should. So that is basically what you can do. Now for units, you just check if they are inside the area 3D to be visible, and if not, then we can hide them. And that's basically how you can do Fog of War just like Age of Empires. And as you can see, it works pretty well. Now regarding the Fog of War texture, I believe you can put it outside of the screen. So to you not show it, I think we can actually do this. And let's see if that works. So it should not be visible on the screen anymore, and you should still see that. Now the issue with you turn it hidden is because it's a viewport. I don't think it's going to work if it's hidden, so you have to move outside of the screen, but I'm sure you can figure out something using the viewport here to still update it. So that is how you make it. So to give a quick briefly rundown, we generate a texture using the Fog of War texture controller here. And we do a lot of things here. We basically generate the image. So we generate a Fog of War image for the Fog of War texture. Then we keep a list of Fog of War units. Then we dissolve the Fog of War texture. Then we finally save the sub viewport as a texture inside of our Fog of War texture here. That saved texture gets stored on its variable, and every time it updates, it emits a signal, so that whenever it changes, our map match can ask for its texture, so we can update here on the source texture Fog of War shader. So then we can finally have the Fog of War working as it should here. And the objects stay hidden until the area 3D collides with them and they display it. So thank you guys for watching. That is everything for this tutorial, and I hope to see you on the next one.